Welcome to Amplified Education, your exam prep friend. Today we are looking at grade 10 electric circuits. Please pause the video and try the question on your own. The question reads, the circuit diagram shows a circuit consisting of a battery of negligible resistance, 2 ammeters also of negligible resistance, 3 resistors, and 2 high resistance voltmeters. The reading on A1 is 2 amps. The first question says, define the term resistance. 1.1. Resistance is a material's opposition to the flow of electric current. One point two says we must calculate the total resistance of the circuit. Now you would notice that there are two sections of that circuit that have resistance. Firstly, we have the 18 ohm and we have the parallel branch. Okay? So this is your parallel section of the circuit, right, which has its own resistance, and you also have the 18 ohm connected in series to the parallel branch. So we must first find the equivalent resistance of the parallel section of the circuit, and to do that we could say R parallel is equal to 6 raised to the minus 1 plus 12 raised to the minus 1, raise everything to the minus 1, and then we can get our answer there. So 6, raise that to the minus 1 plus 12, and then you raise that to the minus 1, and then raise everything in the brackets to the minus 1, and then you would get 4 ohms. And then you can then find R total by adding your R parallel with your resistor in series. And that would be 4 plus 18 gives you 22 ohms. And that's the total resistance of the circuit. 1.3 says we must define the term current. And current would be the rate of flow of charge. And that is given by the equation I equals Q over T. 1.4 says we must calculate the amount of charge passing through ammeter A2 in 3 minutes, and that is worth 5 marks. Now we first need to find A2. So A2 is here, right? It's connected there in series. And we must also not forget that we were told that in A1, so A1 takes 2 basically as a reading of 2 amps of current. So that means, so here's A1 there. So A1 is there, which means the 6 ohm resistor gets 2 amps of current. And for us to find A2 first, the current flowing through A2, we must find the current that is flowing through the 12 ohm resistor. To do that, we know that the voltage over the 6 ohms is equal to the voltage over the 12 ohms because those two are connected in parallel. And so IR 6 ohms is equal to IR 12 ohms. Now we know the current flowing through the 6 ohm is 2 and the resistance of the 6 ohm resistor is 6. The current flowing through the 12 ohm is what we're looking for, but the resistance is 12. So if you divide both sides by 12, you will get 1 amp. 1 amp. Now that makes sense because first and foremost, the 6 ohm resistor has less resistance, so more current flows through it than the 12 ohm resistor. But again, what we are seeing there is that the ratio of the resistance, which is 6 is to 12, is a ratio of 1 is to 2. So that's the ratio of of resistance, which means the ratio of current must be 2:1. And that's the whole idea that we are seeing there. So in order for us to get that, we can see that the current that is flowing through the 6 ohm resistor is 2 amps. So if the ratio of current is 2:1 over those resistors, then the current flowing through the 12 ohm would be 1 amp, basically. Because remember, resistance and current are inversely proportional. So if current increases, then, well, if resistance increases, then current must decrease. That's the whole idea behind that. And so indeed, the 12 ohm resistor should receive less current and the 6 ohm resistor should receive more current. Now, that is current in the branches that when it leaves this junction, it combines to about 3 amps. So 2 plus 1 there equals 3 amps. And so the total current in the circuit, I total, is equal to the 2 amps plus the 1 amp. And that gives us 3 amps. But the question is asking for the amount of charge that passes there in 3 minutes. So we are going to say Q equals IT. We already have the current, which is 3. And then we have 3 minutes, which needs to be converted to seconds by multiplying that by 60. And so we have 180, multiply that by 3. And you get 540 coulombs. Okay. Then 1.5 says, how does the potential difference across the 6 ohm resistor compare to the potential difference across the 12 ohm resistor? So they would be equal. So we have to write equal to, and we have already said that in parallel circuits, the potential difference is the same, right? They do not share voltage. They only share the total current, but the voltage is constant. So voltage is constant in a parallel circuit. Right. Then the next question, 1 points. Wait, that was 1.6 because it says provide a reason for your answer. That was 1.6. Voltage in a parallel circuit is actually constant. Okay, 1.7 says you must define the term voltage, and voltage is the work done per unit positive charge. And 1.8 says we must calculate the energy transferred by the battery as the circuit operates. Okay. So to do that, let us see, did they give us the voltage over the battery? No, they didn't. We would actually have to find the voltage of V3 first. Okay, so to do that, remember, we already have the total what? The total current in the circuit and the total resistance. So V load, right, or VT or V3 would be equal to, remember V3 is over the battery, is equal to IR. The total current is 3 and the total resistance is 22. So the total voltage is 66 volts. So in order for us to find the energy transferred by the battery, we would say W equals VQ. We already have 66 volts from the battery and yeah, VQ. So now we have to find Q, but we don't have, well, the Q, we don't have Q, right? We don't have Q at the moment, but what we can do is that we could say they calculate the energy transferred by the battery as the circuit operates, let's say for 10 minutes, say for 10 minutes. So if the battery transfers energy for 10 minutes, how much would that energy be, right? So now we have the if obviously if it said per second, we wouldn't need to add that 10 minutes. But I'm just saying, let's say it said in 10 minutes, how much energy was transferred by the battery in 10 minutes. So obviously, here you do have V, which is 66, but you also need to convert the Q to IT. Remember, I equals Q over T, so Q equals IT. So multiply that by IT, all right? And then once you have that, you can then substitute, right? You can then substitute your 66 volts. Your current in the circuit is 3. Now you have 10 minutes, but you must convert that to seconds by taking the 10 and multiplying it by 60. And you would have your energy then in joules. Let's multiply that out quickly. 66 times 3 times 10 times 60. And that would give you 118,800. If the question says how much energy is the battery transferring per second, then you wouldn't need to obviously worry about that part, okay? Because you would take the current anyway and multiply it by 1. You'll take the current and multiply it by 1 second. That's pretty much how you do that. Then 1.9 says if the 6 ohm resistor burns out, will the reading on A2 increase, decrease, or remain the same? So obviously, if the 6 ohm resistor burns out, that circuit becomes a series circuit, which means the total resistance of the circuit would actually increase. So if the total resistance increases, then the current in A2, which is the main current, should decrease. So obviously, there you say the A2 reading would decrease. Then 1.10 wants the reason. So remember, you are changing from a combo circuit. Why do I call it a combo circuit? Because it has 2 sections, a parallel section and a series section. So you can either have a series circuit, which has all resistors connected in series, or a parallel circuit, which just has only parallel resistors resistors connected in parallel, or a combo circuit where you have a section that is in parallel, another section that is in series. So with that being said, you could say now the total resistance has increased, because in order for you now to find the total resistance, you must add those resistances. And 18 plus 12 now is 30 instead of the 22 that we found earlier on. So now the resistance is bigger. All right. So the total resistance has increased because the resistance now, when the 6 ohm burns out, is 18 plus 12, which gives us 30 ohms rather than the 32 that we found earlier on. So if the total resistance increases, because resistance is inversely proportional to current, then it means if resistance increases, then the total current should decrease. And that is why the reading of A2 then actually decreases. I hope that helps. Thank you.